Now let's see theorem number 30. Yes, theorem number 30 on page 51 of our number theory book. Yes, very important theorem. I think this theorem has been asked in a previous exam. So what is statement? There are infinitely many primes of the form 4n plus 3 where n is a positive integer. See, there are infinitely many primes of the form 4n plus 3 where n is a positive integer. Most of the theorem we will prove by contradiction. Yes, so here also this proof we are going through by contradiction. We prove the theorem by contradiction. Yes, means what? They are giving us there are infinitely many primes, and by contradiction means we have to assume that there are finitely many primes of the form 4n plus 3. Yes, proof is simple, very simple. If possible, assume that there are only finite number of primes. Yes, number of primes of the form 4n plus 3. ओके, स्टेटमेंटमध्ये आपल्याला इन्फिनिटली मेनी प्राइम्स आहेत 4n प्लस 3 फॉर्मचे असं प्रूव्ह करायचं आहे. आणि आपण काय बाय कॉन्ट्रडिक्शन काय घेतलं आहे की ते फायनाईट नंबर ऑफ प्राइम्स आहेत. ओके, लेट सिंपल प्रूफ आहे. लेट द कंप्लीट लिस्ट of such primes b. Yes, so first prime we are taking 3. Why not 2? Because they have given 4n. 4 means 2 into 2n plus 3. So here already 2 is present, so we cannot take here p naught is equal to or p0 is equal to 2. Okay, and p1 p2 up to pr is a finite number. Yes, because we are assuming what? Finite number of primes. Yes, consider a positive integer. Yes, consider a positive integer. A is greater than 1. Yes, we can write a as factors of multiplication of factors of prime. Okay, and we can also write a as 4 because we are considering positive integer. Yes, so 4 p1 p2 up to pr plus 3. So you see here we are starting from p1 not from p0. Yes, okay, call this as equation 1 where each pi is of the form 4n plus 3. Okay, now let's see. We have taken a is greater than 1. Yes, so we can also write a as product of prime numbers q1 q2 up to qs. Okay, call this as equation number 2. Yes, where all q1 q2 qs are primes. Okay, are primes, and where we can write here qs are of the form 4n plus 1 or 4n plus 3. We have already seen. Yes, all primes are of the form 4n plus 1 or 4n plus 3. Okay, if suppose if all primes or all these qk's, yes, all these qk's are of the form are of the form 4k plus 1, then what happen? Yes, then A has the form, yes, then A has the form 4k plus 1. But see, in equation 1, what is our A? A is of the form 4n plus 3, and here we are, what we have taken here, A has the form 4k plus 1. This contradicts from equation 1. Yes, this contradicts from equation 1. So A has contradicts of A. Okay, hence at least one of our QKs must have the form or must be the form 4n plus 3. अंडरस्टूड. आपला जो ए आहे तो त्याचा फॉर्म 4k प्लस 1 नाही राहू शकत. मग जे काही क्यू केज आहे, आपण हा जो ए इथे इक्वेशन 2 मध्ये डिफाईन केलेला आहे त्यापैकी एक Q1 Q2 Q3 QS पैकी कोणताही एक क्यू केज काय असणार आहे, 4n प्लस 3च्या फॉर्ममध्ये असणार आहे. का तर आपण ए जो घेतलेला आहे तो 4n प्लस 3च्या फॉर्ममध्ये घेतलेला आहे. ओके, सी this proof. Yes, write down after that. See, hence one of the QKs must be some members of P1 P2 up to PR. कोण एखादी Q1 Q2 QS जो आहे तो P1 P2 PR चा मेंबर असला पाहिजे. लेट दिस बी PI. ओके, देन RHS of equation 2, yes, contains PI. Yes, so this implies PI divides A. Call this as equation next. Equation next means equation 3. Okay, equation 3. Okay, what is our A? A is equal to what? 4 P1 P2 up to PR plus 3. Yes, here in this term there is no 3. Yes, so what we show that 3 does not divide A. Yes, काय शो करायचं आहे आपल्याला? व्हॉट वी हॅव टू शो दॅट 3 डज नॉट डिवाइड A and this P1 P2 PR. Okay, so this PK also does not divide A for K varies from what? 1 to, or here not take PM. Yes, here M varies from 1 to R. Okay, assume that now we have to show that what 3 does not divide A and this term does not divide A. Yes, so assume again by contradiction. Means what? Assume that 3 divides A. Yes, 3 divides A and we know 3 also divides 3. Yes, so this implies 3 divides. So by theorem 2, in previous section we have learned, read theorem 2 of this book. Yes, theorem 2 of this book means if 3 divides a and 3 divides 3, then linear combination of these two numbers will be divisible by 3. This is the theorem number 2. Yes, so means this is linear combination of a and 3. So 3 divides a minus 3. Okay, so 3 divides, so what is a minus 3 from equation 1? From equation 1 value of a minus 3 is what? 4 p1 p2 up to pr. Yes, so 3 divides 4 into p1 p2 pr, which is absurd, means we cannot write like this. Yes, since pi's are prime, yes, primes, all are different from 3. Yes, because we are taking p0 is 3 and p1 up to pr are not multiples of 3 or not 3. Yes, so this implies what? 3 does not divide a. 3 does not divide a. Also pi divides 4 into p1 up to pr, since pi belongs to p1 up to pr, all are primes. So this implies what? Pi divides a minus 4, p1 up to pr. Yes, again by theorem 2. By theorem 2 is what? Theorem 2 is if pi divides a, if pi divides 4 into p1 p2 pr, then pi divides linear combination of a and 4 into p1 p2 pr. This is the theorem number 2. Yes, so this implies pi divides 3. This is again absurd. Yes, because what? Pi are not multiple of 3, or p0 is 3 but p1 up to pr are not equal to 3. This is again contradiction, because pi are all primes except 3. Hence the assumption that there are only finite number of primes of the form 4n plus 3 is false. फायनाइट नंबर असूच शकत नाही. ठीक आहे, दॅट इज देअर आर इन्फानाइट number of primes of the form 4n plus 3, and here we are ended our proofs. Thank you.